Okay, so the solution to the pyramid, if I could speak, volume problem. So we're thinking about, again, we have a square-based pyramid. So all of these edge lengths are measured as 6 centimeters. And then we have measured the what's called the slant height, which is if I go from the base up to the top, straight down the middle of one of these triangles, I get a length of 6.5. We know the volume formula is the area of the base, so the area of this square, which should be pretty simple, 6 times 6, and then times the height. But the height is not 6.5, because remember the height is going to be straight up and down from the base, and if I tilt that, that's going to be a different length. So we need to figure out, well, how the heck would we get this? And to help this, I'm going to think about, again, visualizing it. So what the height I'm actually looking for is if I stuck something straight down the middle of the inside of the shape until it hit the bottom, like this pen is sticking straight through and it's hitting the center of that B. That's the length that we're actually looking for. Now I could like mark something, measure it, take it out, and blah, blah, blah. But if you actually had like a full-size, life-size pyramid, that's going to be something that you probably can't do. You have to use the measurements that you have on the outside. So let's just say that we only have these measurements. To help us out, I have my daughter's lovely decorated whiteboard once again. And I have her sparkly purple box of whiteboard markers. So, again, please try to figure this problem out for yourself first. Draw out the shape. You're going to learn a lot more trying to figure things out yourself. So we know we have the base shape as a square, which I'm trying to draw as three-dimensionally as I can. And then we have a point that everything connects to. So this is the way I draw pyramids, by the way. I just kind of draw the base shape in 3D, draw a point, try to connect everything up. And so what we know is that the base length is 6. And we know that if we took one of these triangle faces, so if we just think about this triangle face on the outside, and I connect the top down to the bottom middle here, we know that that's a length of 6.5. And the length that we're actually looking for is in 3 dimensions, going down from the top to the center of the square. Remember, we have the center of the square. Maybe I will draw the rest of that kind of 3D stuff in the background back in here. So we've got this point on the center of this background square on the base. It goes straight up to the top. That's the length that we need. What you might be able to see here is a right triangle. So the hidden right triangle is connecting this point to this point, and that line along the bottom would be half the distance across one of these sides. Remember, the distance across one of the sides is 6, so this length is going to be 3. And so we have this length of 3, and maybe I can get a little closer here. We have this length of 3, and then what we want to know is that height. And we know this length is 6.5. So we actually have a right triangle that has a hypotenuse of 6.5, and it has a base length of 3, and then it has a height. That's the question that we want to figure out. So that would be our right triangle. So that's this shape inside of the three-dimensional shape. We have this two-dimensional right triangle that's kind of floating in the air here. It's a little hard to see in my picture. My sister's a graphics designer and great artist, and I am not. So we've got a right triangle. So we should be able to solve for this by doing the leg squared plus the leg squared equals the hypotenuse squared. I'm not going to worry about matching colors right now. We'll just go 3 squared plus h squared equals 6.5 squared. So that's all we need to solve. 3 squared is 9. 6.5 squared is not something I'm going to do in my head on live video for the sake of making mistakes, but I am pulling out a little handy dandy calculator and cheating here. It's 42.25. 42.25. So 9 plus h squared equals 42.25, so we can just take away the 9 off of each side, get that h squared equals 9 less than 42.25, which is 33.25. And then to get rid of the square, we do our little square root. So our height is the square root of 33.25, and I am going to square root that. So that is approximately 5.8 if I just do 1 decimal point. Okay, so we get that the height is about 5.8. That's the hard part of the problem. Actually using the volume formula, once you know the height, is pretty easy. The volume of the pyramid is going to be the base area times the height, and then times 1/3, or you could think of it as divided by 3. Either way you want to think about it. So the base area is just the area of that square, which in this case will be 6 times 6, so that's 36. And now it's going to be times the height, which we just figured out is about 5.8, and then it will be times 1/3, or you could think of it as divided by 3. Those are the same thing. So I'm just going to run through this little calculation on my little calculadora over here. So I've got 36 times 5.8, and then that's 208.8, and then I'm just going to divide that by 3. And we get 69.6. All right, so if you got somewhere around 70, 69.6, somewhere around there, depending on how we might have rounded differently from each other, then you got it. And yeah, so that's the idea. If you have the actual just height of the pyramid given to you, these problems are a lot easier. Just area of the base times the height divided by 3. But I wanted to show you one where the height isn't given for you. Usually you have to create some kind of right triangle inside the shape where you know 2 of the lengths and the other length you're looking for you solve with the Pythagorean theorem. As usual, if you have questions, just let me know and I can help out.